All right, should we get into it? Okay. So last week we spent some time talking about our dynamic simulation system inside of Modo. Today, in every sense, we're going to build upon that foundation and that architecture that we established last week. Today for our homework, we're going to be doing something kind of fun. Okay. Today we're going to be making a domino rally. You guys know domino rallies? Yeah, you guys have probably seen them before in other capacities. This is where people like stand up a whole bunch of dominoes vertically in like a really cool pattern. And then they push one, and then they all kind of push around and collapse into this cool spirally shape. Okay, so we're going to be building a small animation. Okay, right around 10 seconds. Okay, that is focused on a domino rally. Now the cool thing about this is that you have to take everything that we've learned about rigid body or just dynamics as a whole and apply them into kind of your own animation. So you're going to have to come up with the idea behind this. You have to come up with how all these dominoes, are going to work together. Are there other elements in there that are going to influence the dominoes themselves, right? Maybe you want to have like a ball like go down a ramp which starts the domino. You can be super creative in your animation. Yeah, think Rube Goldberg's, and we're going to look at some of those towards the end of class today to get your creative juices flowing a little bit. However, before we get started, we have to talk about a major feature inside the dynamic engine and Modo as a whole called replicators. Because everything, not everything, but a lot of the stuff that we're going to be looking at going forward should include replicators at their core. Now, one of the things that you're going to struggle with as you start to create more complex scenes is having the computer manage the scene a little bit more efficiently. Okay? With the complexity and the level of detail of our computer graphics industry skyrocketing, how we manage and create this high-resolution detail is important. So thus enter the role of replicators. Okay? Now before we get started, I think a point of comparison is really important here, because I think this comparison shows the benefit of replicators, and it allows us to start creating some really detailed scenes, but not at this crazy overhead that we'd normally have with a traditional workflow. Let's check it out. It's pretty neat. Okay, so let's do this. Yeah, okay. I have a crazy idea because it's Friday, and I'm full of crazy ideas on Fridays. I'm just going to make a ground plane here real fast, okay? And then I'm going to go into my mesh preset library, and I'm going to load in a car. How about we have a little Alfa Romeo? This Alfa model comes with Modo. It's been around forever. It's a great model. Let me turn off the visibility of my Verts real fast. Oops. Okay. So this is just an example. If you want to follow along, I've gone into the Layout tab at the top of the screen. Then down at the bottom of the Layout interface, it's split vertically, and you'll find your Mesh Preset browser. Specifically, I'm in the Meshes tab here, and I've traveled over to the Automotive subcategory. Double-clicking on any one of these icons will load the mesh at the origin of your scene, and you can start to work with it inside your larger context of your scene. Okay, so this is what I got going on here. Let me just make my ground plane much bigger. Okay. And what I want to do is start duplicating this Alfa Romeo. Okay. Using a traditional workflow, duplication at the item level is still pretty easy. Luckily for us, the tools inside of Modo allow us to duplicate basically at any level within inside of our geometric structure, if you will. I don't want to duplicate the wheels. I want to duplicate the entire car. Upon inspection, you can see that this car model is, pretty detailed. Let's just get an understanding. How many polygons are we working with here? So this has 49,000 polygons. Okay, so it's a pretty good looking mesh. Most of them are subdivided, which is, it's got a cool interior too. I really don't know who made this model. Whoever did a wonderful job. Yeah, really great job. Even appreciate that they modeled like on the inside. They modeled like the buttons to open and close the doors and the windows and stuff. That's just good modeling. It's good practice, right? Anyway, okay. So it's a pretty detailed mesh. Now let's go ahead and start duplicating it. and see how fast we can break Moto, because that's my goal right now. Is I want to see if I can bring Moto to its knees. Because in the larger context of my imagination here, I want to create an entire city street scene with skyscrapers and roads and lamps, and of course I'm going to need a whole bunch of cars on a road that I can animate. Okay, so I need a whole bunch of alphas right now, a whole bunch of them. Let's start duplicating them. I'll jump over into item mode, and under my duplication collection of tools, let's just make it real easy initially, and I'll just do a straight up clone. There's another one. And Moto's already starting to get really slow. So let's put, oh, I don't know, 5 of them in here. There it is. Okay. Now, when you do a straight up item duplication, all of the polygons naturally and all their p tags in the shader tree are also duplicated. Okay. It's definitely a what you see is what you get, but it's incredibly inefficient, right? Incredibly inefficient, because we've now added a tremendous amount of independent geometric resolution into our scene. All of these polygons are still independent from each other. The computer's not seeing and working with these any different than any other polygon, right? So they're all kind of at the same level of efficiency inside of our three-dimensional scene. So let's go render. Let's render this thing. Oops. Okay. There we go. Awesome. The render camera is just like, I'm not going to work today. No, it's seeing it's there. Okay, why? No, they're underneath. Is it me? Or is it preview? No, it's just preview. It's actually rendering them out. It's actually what I wanted. Preview's choosing not to work today. It's Friday. It's taking the day off. I'm just curious. I really don't know the number on this. Let's just see how long it takes to render. It's not too long, maybe 30 seconds or so. And most importantly, we can get a good understanding of the efficiency of our three-dimensional scene. Now, what we get with this level of duplication is direct control, absolute independent direct control over each one of our duplicates, okay? Even down to the polygonal level. So everything's kind of a first-class citizen, if you will, inside of our scene. We haven't changed the dependency of this in any way. There we go. The rest should be pretty easy. So what? It took 48.5 seconds, and I rendered 5.96 million polygons, okay? And one of the things that we have to really start considering now is the memory, okay? The memory section of our stats, our render stats, is now something that we have to play or have to have a little bit more direct understanding of. This is, in every sense, this is how much memory is being used on your machine, your RAM, right? Now, what's the purpose of the RAM on your computer? Pop quiz. What does RAM stand for? Random access memory, right? What's the purpose of your RAM? That's exactly what it is. It's just temporary storage, right? It's like a gigantic temp file or a cache file for all the stuff of your computer, right? Now, every single application that's open and every project that's open is going to put a little bit into that bucket, right? Because that's kind of how I imagine it. It's just a gigantic bucket of data that's on your machine, right? Once that bucket fills up, the stuff that's the oldest is going to start being removed, okay? And so the computer's always filling the bucket and taking out the old stuff and replacing it with new, right? Different apps dominate your RAM differently, right? Like Photoshop was renowned in its early stages for basically taking over your RAM, right? If you had a gig of RAM on your machine, it would take 950 megabytes of that RAM because it would just, to get the best, most fluid experience in the application, it just gobbled up all that RAM and the OS allocated it to Photoshop, right? Now that we're rendering big scenes, we need to manage how much memory that scene is requiring of our RAM, right? So right now it's saying geometry cache, 655 megabytes. Okay. 655 megabytes of data have now been temporarily written to your RAM. Okay. Let's write that on the board. Start making some comparisons, because I'm going to forget this stuff if I don't write it down. So we'll just do, I'll put iClones for item clone, or I'll put IT for item clone. Okay, so it took, what, 47.5 seconds? And it was I think it was 596 million polygons. That's not how you draw an M. Got a little carried away. Million polys. And it took up 655 megabytes of RAM. Okay, cool. All right. Now, let's explore how we can change this a little bit, right? Because this item level duplication is not the only one that we have at our disposal, right? There's actually two other types of duplication that will fundamentally do the exact same thing, but they're going to give us very, very different results, okay? So, let me see if I can get old preview to work here. Why is preview not choosing to work? It works now. That's all that matters. Okay. Okay, so what I'm going to do now, this is going to seem kind of strange, but I'm actually going to delete all of the duplicates. I'm horrible with lists, by the way. There we go. All right, and I'm going to return, again, back to the original Alfa Romeo. However, this time, I'm not going to do a straight-up item clone. I'm going to do a special type of clone called an instance clone. Now, we've talked about instancing a couple times before, especially if you've taken GCOM 402. What in the world is an instance? Yeah?
It's like a clone that affects the original and it'll affect the rest.
You got it. You got it. So it is a clone. It is an item. So we can still move and scale and rotate it around our three-dimensional scene. But what we can't do on the instance is go in and edit the geometry. The geometry of an instance is being referenced from the original mesh, okay? Which is pretty great, because now when we change our original mesh, all the instance clones will update at the exact same time, okay? It makes it a real nice workflow, especially when you want to have a lot of things that look identical, but you don't want to have to manage all the polygons. I did this once. I use instances all the time. It's pretty fantastic. The example that's popping into my brain right now is, you remember that big pirate ship that I made? Did I show you that? The HMS Victory. It's not a pirate ship. It's just it's a British warship. On the back of the warship, there's there's kind of the captain's cabin on the back, and there's a zillion little spindles. Okay, a zillion of them. It's kind of an ornate piece of the model. And man, I instance cloned all of them, and when I made a change to the root model, all the instances updated their geometry at the exact same time. Let me show you what I'm talking about. It's pretty neat. Once again, in order to fire this off, you have to be in item mode. It's a little bit hidden, but it's not too hidden. There's two ways that you can enable the computer to fire off an instance clone. First and foremost, you can hold down the Option key, and you can see that all the colors of our icon change from that kind of purpley blue to a lovely shade of pink. Okay, that's one way of doing it. In addition, if you notice on most of these tools here, there's a little dark arrow in the lower right-hand corner, which brings to you, there it is, instance clone. So those are the two ways you can fire off the tool. They are, in every sense, identical to each other. And now, let's go ahead and do it. And you can probably already see that my performance inside the OpenGL viewport is just almost butter smooth. I'm not getting that same performance hit like I had before.
Why is that?
Well, because all the geometry is being referenced back to the original, right? So the computer's not having to manage in its back-end database, all the local, all of its local understanding of the surfaces on each one of those items. It's only trying to understand the surfaces on the parent, but then figure out the location in 3D space of all the instances, okay? Now instances, we can, since they're an item, we can go through our exact same item level workflow that we've been going through the entire semester. So I can grab an instance, okay, can select them, can move them around a little bit if I'd like, you know, so I can have a little fun. They do this in car commercial all the time. We like to have a fleet of cars traveling. It's the flying V. I'm just assuming that everyone loves the Mighty Ducks, right? It's the flying V of cars. Let's go back over to the render and see what type of performance gain we get. Now, I'm going to change my render camera just ever so slightly here. Let's render again. See what we get. I really don't know what the time's going to be, but you will get a performance gain in this entire process. Let's see what it turns out to be. We need a rendering song, right? Not the Jeopardy song, though. Something new. Something fun and happy with like a celebratory woo at the end, right? All right, here we go. Let's see what we got. Boom! Check that out. 34.8 seconds, okay? So instances, and I'll just put iClones. This is the instances, right? So 34 seconds. What was my geometry cache? Check this out. Look at this. The geometry cache just, there it is. Geometry, 109 megabytes. We went from 655 to 109 megabytes, okay? And the number of polygons that I rendered out, same, 5.96 million polygons. So we're rendering the same amount of information, right? The same number of polys, but more efficiently by a magnitude. Let's see, we've shaved off 13 seconds just on the render time alone, okay? That is a huge performance gain, okay? By a magnitude, that's a huge performance gain. You know, if you're shaving off a second, that's cool, but when you're shaving off tens of seconds from your render, that starts adding up pretty quickly. Very quickly, okay? And we're making a more efficient scene by keeping our geometry cache and just the RAM requirements much, much smaller. Now, in the grand picture of things, what's going to add into our RAM? What's going to be a contributor to our RAM? The surfaces, the physical point information from the geometry is one. What else is going to start dominating and taking up a lot of our RAM? A little bit, yep. More so than that. This model doesn't have very many textures, okay? Textures start to dominate our RAM pretty intensely. Now, for a lot of the things that we've done so far in our class, the texture load has been pretty light, but I've worked on scenes where everything has 4 or 5 textures on it, everything, and there's probably 200 different objects in the scene. So you can see that, you know, that little bucket's going to get full pretty quickly. What's going to happen when the bucket's full? It's actually not slow as in molasses, it just won't render. Yeah, it won't, basically the computer says, out of memory, I can't render, okay? RAM is a really important, yeah, no, I was like, I'm done, nothing I can do about it, man. You got to fix your scene, right? That is the worst moment that you can, I've had that a number of times, recently actually, where I'm like, sweet, I'm ready to render it, hit the button that says out of memory, what? And now you have to say, well, what can I do to make it more efficient so I can kind of, you know, make sure my scene can render, okay? All right, so instances are pretty fantastic. I love working with instances. Not only is there a pretty significant hit in performance gain upon render, as I was mentioning earlier, all the geometry is being referenced back to the original. So I'll do it simply here. Let's see if I can find an example that's real easy to see. So let's just grab the roof of my car. Okay. And now when I make a change to number 1, all of them update at the exact same time. Because all the instances are referencing back to the original, okay? Mike said, I wish I had known this with my bricks. Absolutely, because instances are items. We can make them active or passive or kinematic rigid bodies inside of our scene, and we're going to have a tremendous performance gain.
So if you were to animate with the instance clone, would it also follow that or not?
No, because each one of these are separate items, right? Our animation, all the keyframes are placed on a single item. Yeah.
So you still have to separate.
Still got to animate them individually. Yep, still got to animate them all individually. Yep, faux show. I've given my little Alfa Romeo like a camper
Too much.
bubble on the top, right?
Or a giant police siren.
That's too much instances.
What? What did you say?
Or a giant police
A giant police siren, yes. That's awesome.
Or a mounted machine gun.
There we go, right? Yeah.
I was going to say, looks like it has.
It looks like it has it. Yeah, I love it, right?
Can you like do an instance copy of like a texture?
Kinda, yeah, you can actually. You can. Let's see, I'm not sure if this particular alpha has a lot of textures in it. Here's one, okay? I have no idea what this texture is. Here, let's double click on it, see what we can see. It is that, whatever that is. I don't know what I'm looking at. Yeah, or it says 3 stops, so maybe it's on the back here. I bet you it's one of these things. Anywho, doesn't matter. You can make an instance of it to save some RAM, okay? Like let's say if I wanted to use this in another material or in another capacity, like a bump map or displacement map, you right-click on it, create instance of a texture, so that capacity is still available to us. It doesn't completely eliminate its overhead inside of our RAM, but it reduces it significantly. All right. So, as I mentioned earlier, this is one of 3 ways that we can duplicate things. And hopefully you can start seeing the method to the madness, okay? What's great about instances is that we can still animate them. They're traditional, independent items. The only thing we can't mess around with is the geometry, right? Everything else, fair game, fair game. At times, though, we don't need necessarily to animate one of our instances. Consider this. What about all the buildings in a little skyscraper scene? We're not going to animate the buildings, right? There's going to be static objects in the scene. What about all of like the light posts, or the fire hydrants? Okay, there's static objects that aren't going to move at all, but we're going to need a lot of them, right? The level of detail that we're creating in our scenes geometrically is astounding, right? It is amazing how much folks are modeling these days, right? Some things need to move, some things don't need to move, okay? So let me show you the third component in all of this, which is called a replicator. Now, replicators are very different because what they rely upon is something that we haven't discussed in any other class, and it's called a point source, okay? Which is fundamentally just the whole series of verts, okay? The verts are going to be the determining factor as to where our replicas are placed inside of our 3-dimensional scene. So the first thing that we need to do is create a point cloud, vertexes. That's all we need, right? Something inside of our 3-dimensional scene that defines where our replicas are going to live, okay? Then we create what's called a replicator, and then we start literally wiring all these components together and have the computer duplicate for us, okay? Let me show you how it works. It's pretty easy. I'll just kind of rebuild this example once again. I don't need all of my instances anymore, so let's get rid of them. Yes, I'm really sure. There we go. Okay, so now what I need is a point source, okay? And this is what's really kind of strange and really kind of wacky and weird, okay? Let's create a new mesh item. And I'm just going to call this car point source. In this process, I can't emphasize enough the importance of naming your mesh items, okay? If everything is going to be named mesh, trust me, you're going to mess up. You're going to start mixing these things up and cross-wiring them incorrectly together. So the Alfa Romeo is going to be what we're going to duplicate. And this is going to determine where all of those alphas are going to be duplicated, okay? So on our point source, we need to physically go down and start throwing down some verts. If you're following along, definitely make sure you go into your active meshes section of your viewport property and turn on the visibility of your verts, okay? I'm just going to do always. And to make it easier for you guys in the back of the classroom to see what's going on, I'm also going to enable independent point size. That way my verts are nice and big and chunky so you guys can see them in the back. Okay? All right. Now, this is kind of cool. I'm going to go over into my vertex collection of tools. And we actually have a vertex tool at the top. You ever wonder what this does? It's just going to create a vert. That's all it's going to do, a single dot in space. Now, in the traditional 3D modeling pipeline, a single dot is kind of meaningless, right? It doesn't really have a role. It doesn't add to the 3D modeling process at all. But in the duplication world, especially when paired with replicas, and we'll talk about the application of this in particles here in a minute, okay, verts have a very big role, okay? So the vertex tool is going to allow us to very quickly just add verts around our scene, okay? Now, I'm trying to remember. I'm just clicking, by the way. How many did I have? I had 6 of these alphas. I'm trying to make the exact same thing. There it is. Okay. Now, if I drop the tool and look at what I've created, you can see that I've added, what, 1, 2, 3, 5 verts into my scene. Okay. When I add the replicator and start wiring all this together, I'm going to have an Alfa Romeo at each one of those verts. Okay. So let's do it. It's pretty neat. Let's go ahead and add it in. Now, replicators are pretty fantastic. I love replicators. They have in every sense changed my modeling and 3D workflow. That is pretty fantastic, especially when we're working with high-resolution scenes. Okay? We find them under the Add Item pull-down menu. They're under the Particles section. We'll talk more about particles here in a second. If we look at the icon for a replicator, you can see that it shares that common convention that we've seen a little bit today, the little blue cube, right? The blue cube is the mesh item. The pink cube is an instance. And what would you call that? Purple? Is it purple? Pinkish purple?
Lilac.
Huh?
Lilac.
Lilac? It's purple. Maybe we just go with purple, okay? And then the purple cube is the replicator. Now, notice that the replicator, when we first created it, is all grayed out, okay? Because we had to go in and establish some very important properties on the replicator that links all of these different mesh items together and generates the replicas themselves. So with my replicator selected, I can go down to the bottom of my screen into the properties section, and specifically, I need to go into the instancing section. Now, the prototype, this is what's going to be replicated. So in our sense, we want to choose the alpha, right? I want to duplicate my Alfa Romeo. Okay? The point source, this is the mesh item that contains all of the verts. So for me, car point source. See why it's important to name things? Okay, yeah. When you have a list of 50 different mesh items in your scene, this is a big help. Now, when I click on it, it's going to do it instantly. So, bloop, there it is. Congratulations, you just made your first replicas. Okay. Now, this is great. Inside the viewport, what they're displayed is bounding boxes, but we can change this. Okay. If we wanted to actually see what we're replicating, we can certainly do that. One of the reasons why replicas are so awesome is that we get the ability inside the viewport just to display them as bounding boxes, if we'd like, which makes our scene very, 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 very light. Okay. However, if you really, really want to see your replicas, you can go into your viewport drawing properties, and here it is, replicators. Mine's currently set to none. However, you can do selected or all. Okay, I would be very wary in selecting all, but using the selected option allows you to filter. Let me turn off my vertexes now because they're kind of getting in the way. There we go. Oops. Select my replicators again, and there they all are, sitting pretty inside of my scene. Now, on the surface, you're probably saying, Pat, this is cool. Okay. It is pretty cool. And I'm going to start to unravel some extra features that make it even more awesome. Okay. But one of the things that a lot of folks get confused about is like, how do I control this? Maybe I want to change the location of one of my cars inside of my scene. What do I need to move in order to change the location of one of this stuff? The vert, okay? The vert that we created on the point mesh, or the point cloud, okay? The point source cloud, excuse me, is responsible for determining where a replica is going to be created, okay? So if I wanted to continue spacing these out a little bit, I need to go back to my point source, okay? Of course, naturally, vert mode is where I need to be. And you can see that when I move it around, all the replicas move around as well, okay? Now, if we start rotating them, this is weird. Because we've just tried to do something that we haven't really actually ever done before. And rotate a vert. Rotate a vert. Have we done rotating verts before? No, I don't think so, right? We've never had the need to rotate a vert because in the traditional modeling sense, we always rotate an edge or a polygon, right? We've never, and an edge is really created by two different verts, okay? Polygon has three different verts associated with the surface, but individually, we've never had to worry about rotating a single vert. Now, we kind of have to. Here's Pat's pro tip of the day. This is an awesome, awesome, awesome trick. One that I wish someone would have shown me a long time ago in a galaxy far, far away. We can create what's called a transform map that will store vertex rotation data. Okay? So on my point source mesh item, I'm going to go over into my lists tab, and they're really easy to create. Just in the other maps section, we'll create a new map. And in the popover that pops in, the vertex map that we want is not RGBA. We want transform map. Did I hit cancel? I may have hit cancel. I can't tell you how many times I've done that. Let's call this Pat's vert rotation. Oh, wait. Oh, it's not other maps, it's particle maps. I'm sorry. When you create it, it's automatically you're going to go in the particle map section. My bad. Okay, so with that map selected, check it out. Now I can go back over. I can rotate my vert. Okay, and that rotation information is being stored inside that transform map. Without this transform map, you're never ever going to be able to rotate your replicas. Okay, because you really can't rotate a vert. A vert just defines location, not rotation. Okay, this transform map does. It stores that rotation information onto the vert itself. Okay, cool, huh? So those transform maps, that's a good one, because you're going to want to use these replicas often, and sometimes individualized control over each one of our replicas is needed. The transform maps gives us that extra layer of control. Now let's really go out and start seeing the direct benefit. I want to move some of these closer because they kind of got spread out a little bit. All right. There's all my alphas. Let's render now. Let's see what we get. It's going to be close. No, it's going to smash it by a couple seconds. Boom, look at that. 5 seconds faster. Same amount of geometry cache. It's still having to render the same amount of geometry. Still 5.6 million polygons, which is what we'd expect. The type of information is still being kind of the same, right, as we had before, but we've shaved off, 5 seconds, which is pretty good. Okay. Where this really comes into play, and this is a cool example, but where this really comes into play are in big, and I mean big scenes, okay? This is probably not a good idea, but I'm going to do it anyways because I'm feeling a little feisty today, okay? I'm going to make a Borg cube of Alfa Romeos because that's how I roll. Yeah, this is going to be awesome, right? Okay, so I'm going to nuke all the points on my point source, and if you really take a step back and look at it, for a replicator to truly work, it just needs verts. How we create those verts, There's 1,000 different ways that we can create those verts, you know? We can just use traditional geometry if we wanted to, okay? For example, a cube. A cube, that's a very awesome ringtone. Okay, a cube, of course, has a whole series of verts on it. Okay, and if I start subdividing it, now I have a whole bunch of verts. Like I said, Borg cube of Alfa Romeos. Okay.
Madman.
Yeah, so I have 1538 verts here. So in essence, I'm going to get 1,500 Alfa Romeos, which is exactly what I want. Okay. Let's go back to, oops, I need to cut and paste this geometry from that mesh item into the other one. There we go. Ha! Since it was all wired up already, just changing the content of my point source updated the replica, or the replicator. And you actually don't need to have the visibility of your point source on. That's pretty sweet. Okay. So this is one of those things where most people would be like, no, Modo is going to break. Everything is going to break if I try to render 1,500 Alfa Romeos. But let's just do it. Let's break Modo today. So A, preview turned on, which is surprising to me that it actually did it. And check it out. I can still kind of zip around and preview. See an endless parking lot of Alfa Romeos, okay, which is pretty awesome.
They're all smart.
Yeah, exactly, right? And now let's render it. Preview is one thing, it's actually rendered. I know, it's cool. See, Indigo's done a Death Star, right? So remember, we were rendering 1,500 Alfa Romeos. Let's just kind of, so I'm rendering 1.53 billion polygons. This is crazy. And what's my memory at? My geometry cache is only 143 megabytes. Only six Alfa Romeos independently was 655 megabytes. See where I'm going with this? If you've ever wondered how the big visual effects and animation firms do their amazing detailed scenery, it's through technology like this. Okay? We're at a point with our technology where we literally can place, light, and render every tree in the forest. Okay? It's no longer kind of an illusion like we had to do before. And I rendered 1,500 Alfa Romeos at 47 seconds. That's pretty cool. That's very cool. Okay? Let's kick this up a notch, because this isn't cool enough, right? Because we can make this even better. Because this, yeah. Let's do this. Let's do a very similar thing to what Indigo's doing, because the sphere actually works quite beautifully to showcase the next idea. So I'm going to go in here, get rid of my point source, and I'll add a cube. My cube is way, way too small. Let's make it bigger. I don't know why I did that.
Oh, because you're in doing a point source, so it's creating the boxes.
Let's turn off my replicator. I need to have a big cube or big sphere. Here. Let's just turn it all off. Okay. I'm also going to unsubdivide it. Okay. And let's see, how big is this in relationship to my alpha? Oh, I've made my point source gargantuan, which isn't going to work for the context of this next bit. Okay. Let's wire everything back in together. There we, oops. Hold on a sec. I need to get back to my bounding boxes for a second. There we go. Get some of my performance back. There we go. I think, yeah, the source mode aligned to surface isn't working. So let's do point data. So I'm interested why that's not working. Here, let's do this. Let's just rebake it for a second. I'm going to make it work. I refuse to lose.
You lost your transform map somehow? When you destroy that?
Maybe. There we go. That's what I'm after. If there was something wrong with my point source, and in the process of teaching, I'm not going to, you know, I can't chew gum and walk at the same time, so I'm sure I messed something up. But so just rebuilding the mesh real fast, you know, solved the problem. It probably was that transform map. When I scaled it up, I scaled up all the transform values too. Okay, so if you look carefully at what we got going on here, same thing, right? Whole bunch of Alfa Romeos just chilling on my surface, okay? Whole bunch of them. Now, at the location of every vert on my sphere, I'm generated an alpha. One of the cool things that's neat about replicators is that since it's kind of a almost programmatic way of duplicating, we can go in and adjust the algorithm a little bit and start giving it some random variation in there too, right? Because we don't want every car to be the exact same size. Maybe not every car is at the exact same angle. So we can go in and give it some like random twist, like a 45-degree random twist along the y-axis. Now they're all starting to go different directions, which is pretty cool. Maybe we have right? Maybe we have random scale. Let's do 75% random scale. Now I got some big ones and I got some small ones, right? If I start adjusting the offset, let's do 10 feet offset, okay? Now some are right down there on the sphere, some are floating off the sphere, right?
That's how they make like the rocks in space and whatnot.
Yeah, you got it, right? The more we can ask the computer to go in and kind of, you know, vary the distribution of these points, the better. Yeah?
For the replicator, do you do like turret that have all point to one direction?
So the question was, can we put like turrets and have them all point at one direction? No, this isn't going to work for something like that. You know, the limit of working with a replicator is that we really can't go in and animate each one of the replicas individually. Yeah, in order for each turret, you know, along the sphere to be pointing at something in a common point, right? We'd have to go in and understand the local position of each. Yeah, no, that's not going to work. Yeah, unfortunately, because the animation system and the rigging system needs to understand the local rotation of each one of them to a constraint or to another object. This doesn't do that.
So, if it doesn't do that, can you still do, like, I have all these things and I want them to drop?
We're going to get to that in a minute.
Dynamic.
Hold on to that thought. The answer to your question is yes. Dynamic replicators is what's coming up next, okay? And that's where it gets a whole lot of fun. We're gonna do a couple other things. We'll come back to that, okay? All right, so this is all well and good. I like this, right? But let's kick it up another notch, okay? Because now what we're really doing is that we are working inside of a particle creation system. We're generating a whole series of verts or particles based off of a sphere, and I want to go in and start leveraging the computer's understanding of particles to start varying the results a little bit, okay? What if I wanted to have the color of each one of my cars be different? You couldn't do that by hand. You wouldn't want to do that by hand. But because the replicas are being generated by the points on the sphere, each replica is being assigned its own particle identification number, and we can tap into that. Okay? Check this out. This is actually pretty cool. I need to go in and find the material property that's responsible for the hood of the car. Let's find it out. Let's find one here real fast. Here we go. All right, so, okay, so let's see here. Yep, okay, so this is the material inside of my shader tree that's responsible for establishing the car color, right? Well, I don't want a material to be responsible for establishing the car color. I want to use a gradient, because I want to use a gradient to go in and define a whole series of colors that my cars could be, and then let the computer then kind of randomly assign those car colors to each one of the points inside of the scene. Of course, it's going to wig out on me right now. Come on, Mr. Projector, come back to me. It's so awesome the projector doesn't want me to show you. Here we go. Okay, so now let's do add layer, and we're going to do processing gradient. Gradients in Modo work very, very differently than a gradient would in like Adobe Illustrator. We're still able to transition between a whole series of colors or values, but we don't get to do it kind of spatially within inside of the screen space, although you can do that, right? Here, we're going to use the input of one object to influence which color value or value, just number value in the gradient we want to be assigned. Okay. So let's go in and start wiring this together. The input parameter is not going to be incidence, right? Which is the angle of the object to the render camera. We want it to be, and I got to remember where it is. Oh goodness. Oh, particle effects. We want it to be particle ID. So we're going to take the identification number of each one of the replicas and then tell the computer basically, hey, assign, they're all white, that's good, and assign a random color value. Well, it's not really random, it's a value that I establish from my gradient. Now this is the gradient, or one of the gradient editor views inside of our properties tab. If you want to, these white rectangles, these are the keyframes, okay? To add into the keyframe, just middle mouse click on this bar. We can add in some values, okay? With each of my keyframes selected, I can go in and tell the computer what color I want it to be. Like I want some to be red. I want some to be a lovely shade of blue. I want the next keyframe to be yellow. How about purple? And last, but certainly not least, green. You can already see what's happening inside of the viewport. Some of the IDs are being randomly assigned one keyframe, and others are being assigned the others. Pretty cool, huh? This is the power of working inside of replicas, all right? Because we're now we're making our system a little bit more intelligent. You know, it's kind of a give and a take. Okay, we lose a little bit of the animation functionality, but we gain a whole bunch of random variation into it. Think of this like something like a tree. If you're if you're replicating a whole forest, you don't want each of the trees to be the same color. The trunks are going to be different. The leaves are going to be different colors. Okay, through this system, we can start to go in and vary all of those properties, almost algorithmically, which is pretty cool. Now, on that note, that's all a question. Yeah, go ahead. I'm sorry.
Is it possible to like animate the replicators and whatnot?
Yeah, we'll get to that in a minute. After the break, we'll come back in and start talking about how we can make these particles move. Because right now they're just static, right? They're not going anywhere, but we do want to make them move. One final thing, kind of even going back to that forest idea, you don't want every tree in the forest to look identical to each other, right? That is a instant, that's an instant kind of tell that this is computer generated. And we just see a whole forest of trees that are identical. You guys have probably seen it. If you look really closely, it's more prevalent than you think, right? Because it's like the exact same tree, and then it's just like rotated. Or some will be bigger, some will be smaller, but it's literally just one model rotated over and over and over again, right? Yeah, it's not a good look. We don't have to do that anymore thanks to replicators, because we can go in and use this exact same system to vary the models that are being created at each vert inside of the scene. Okay. Now to do this is the last thing we'll talk about, and then we'll take a break. And to do this, we have to physically go in and create some models, right? So I'm going to turn off my sphere and my replicator just for a second here. Okay, all right, so there's my alpha. What else do I want here? I want to have me a garbage truck. Just going to think about it for a second. There's my garbage truck. It's got a lot of parts. That's okay. Where is it? Is the garbage truck teeny tiny? Oh, it's also huge. Haha, it is gigantic in comparison to my alpha. So maybe we won't use the garbage truck. Bit much, and it's poorly modeled. Okay. So let's put the hybrid in there. Why not? There we go. And we all got, I love NASCAR, so NASCAR is going to happen. No, I don't actually like NASCAR. Let's just put all these cars in here. There we go. So now I have a bus. I have, a toy car. I have a whole bunch of different cars in here. Okay. There's the hybrid car. Here's the cool race car. Of course, our alpha. And then our NASCAR. Okay. So I want to go in and ask the replicator to randomly replicate each one of these cars along my sphere. So instead of replicating one source item, I wanted to replicate the group. Okay? So we need to make a group first. And here's a great little trick, something that I would recommend that you do. It makes creating groups from existing items really, really easy. It almost speaks to itself, but just have all the participants of the group selected. I just held down the control key as I individually clicked on these, by the way. Okay, let's just do a spot check. Yep, that's it. And then, have you ever wondered what this groups tab is all about? Let's dig into it a little bit, because groups are pretty fantastic. Let's create a new group. There'll be a popover on your screen. Here it is. Let's put it back up here. Let's call it just cars. The mode is from selected items, which is why I recommend that you select the items first. It just makes it a little bit easier getting them in. And then OK. This is how it shows up in the groups list. If you click on the little plus sign and open up the group, you can see its participants. Okay? And you can add and subtract members from the group at any time. This isn't written in stone or anything. It's actually a pretty cool organic workflow.
Can you drag and drop to other groups?
I believe you can, actually. Yeah. If you have multiple groups, you can just left-click and drag them in between them. OK. So now, let's go back over into my item list. Now, I'm going to make sure that all of the group participants' visibility is off. Here's my sphere. Now, on the replicator, okay, it's still just replicating my alpha under the prototype section. However, if we now open this menu back up again, check it out. See how there's one in brackets? That's my group, okay? So instead of replicating individual mesh items, now it's going to look at the group and randomly pick a member of the group to be placed at each vert inside of my sphere. Yeah, cool, huh? Let's go back over and render. So now I got some buses in there. I got some alphas. I got some cars. Some are pink. There's a NASCAR there. Yeah, it's randomly doing it. Cool, huh? And if you don't like it, if you don't like the distribution, like maybe my art director comes in and it's like, there's a lot of buses up there. I go, okay. And the art director will say, can you fix the buses? And I go, well, in this particular situation, I don't have a tremendous amount of control, but I can go in and change the seed on the actual replicator, okay? And this seed value basically kind of randomizes everything over again. There we go, different effect, okay? Cool, huh? Pretty neat. I like working with replicators. They're a tremendous amount of fun, okay? Changes the game in 3D modeling. It really, really does. Sound good? Cool, huh? Let's take a break. We've been going for a couple hours. Let's take a small little break, please. Okay. So, a couple other things here that I want to just kind of explore. So, up until now, our little, our little sphere, all the particles in the sphere have been static. Well, let's get them to move a little bit, and let's get some of our dynamic stuff working together so that we can start actually doing some fun things. Okay. Because if you think about it, remember the original idea behind this is that I wanted to have like an entire city. The city's easy, given what we've talked about so far, right? But how can we replicate like cars on the street that are moving? That's the idea, right? To really begin to simulate potentially what could be traffic, okay? Let's go ahead and do that. This is going to be fun. This is going to be so much fun. You guys are going to dig this, all right? This is all an illusion, okay? Computer graphics is all an illusion, and our illusion begins, of course, in the Setup tab. I'll start wiring some stuff together. Now, I'm going to clean up my scene a little bit. I'm going to keep my replicator, but I don't need my sphere anymore. And great trick, by the way. I want to put all of these items. I can't get rid of them inside of my scene because in every sense, I still want to have these be the root source items of my cars group that I created before, but I don't want them just chilling in my item list like this. So here's a great trick. I want to create a folder. This is just called a group. Okay. Now you could do that by going, where is it? Locators, group locator. Okay. That's cool. Oops. So cool the projector doesn't want to show you to. Okay. Or if you have multiple items selected in your list, Control G will create the group and put all the selected items in the group. Okay? So let's just call this Pat's Car Parts. There we go.
Did you put the point source in there, or did you?
I deleted it because I'm going to create a new point source. In order to get all of these things moving, we have to have a new point source. Up until now, our point source was static. Okay? We need to create a simulation so we can get all these verts to move. Okay? Now there's a lot of ways that we can get a vert to move. Shoot, we could even make a simple control rig using our deformation tools, right? Because if you think about it, I can create green dude. Okay, this is what's creepy about this. I can have him animated, right? And then I can clone and replicate different things to each one of the verts on his body. That's pretty rad. Okay. There's another, I wish I could show you guys everything. There's another system in here that allows us to have a surface, and then I can create what's called a surface particle generator that will analyze the surface, and then we'll distribute a whole bunch of particles across the entire surface for us, and then we can modulate it organically with textures and whatnot. It's rad, right? So this rabbit hole goes very, 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 very deep. The particle system inside of Modo is really robust, and I want to show you how we can create some particles, okay, some moving particles that we then can maybe use to create the traffic in our little fictitious town, okay. So the first thing that we need to do is start examining the contents of that particles tab. All right, dun, dun, dun. Down here. So we were hanging out in dynamics last week, but now we're going to create a particle simulation, okay. Particle simulations have a lot of literal moving parts to them, but we're going to simplify it as much as we can today. And if you want to continue to explore it, I definitely suggest you should. This is a really cool chunk of technology that will add a nice level of detail to the stuff that you're going to be creating inside of your scene, okay? Or that you could be creating inside of your scene. So the first thing that I'm going to do is create an emitter, okay? And there are different types of emitters out there, okay? There's 4 basic ones. The radial, surface, curve, and source emitter. I think for today's kind of illustration, we're just going to create a radial emitter. Okay. Once you create a radial emitter, 2 things are automatically generated for you over in your item list. Of course, we have the emitter itself, but then we have the particle simulation. And think of the particle simulation kind of like the brains behind the entire thing. Okay. To make it easier for everyone to see the contents of my particle simulation, I'm going to select it, and if you go down to your Properties tab, there's a really cool option down here that I would really recommend you change, especially if you have old eyes like me. Just change the size of your particles to something not 1. And I want to have my particles be a lovely shade of red, so that way we can see them. Okay? So let's just play our sim and see what we get. All of our emitters are going to be generated at the, I'm going to turn off the visibility of my texture locators real fast. There we go. All of my emitters are going to be generated at the origin of the scene. And if we start the sim, just like we did last week, okay, first button, the sim is going to run infinitely. And particles will be generated from my little emitter. Is that easy for you guys to see? Let me change the color from red to white. Make it a little bit easier. I thought red was going to be easy, but I was wrong. Yeah, so I have the particle sim selected, and then inside the Properties tab, there is a size and color value.
Okay.
Yep. Cool, huh? Now, one of the cool things about the Moto particle system is that while the sim is running, we can make changes to our emitters and pretty much the rest of the system if we want to start creating a good understanding or attaining a good understanding of how these properties influence what we're getting here. Okay, so that's kind of cool. Yeah. Well, if we really wanted it to snow, I'm in the sim, by the way. Just turn on Use Gravity. Now we got to stop our sim. There we go. And now they're being emitted at the source and then falling inside of our scene. Okay? Not what I want at the moment. We'll come back to that in a second. So I'm actually going to deactivate Use Gravity, and this is what we have. Now I'm going to go back to my radial emitter just for 1 second, because this is really where a majority of your time is going to be spent. This is where you're going to have to tweak a lot of properties and parameters. There's some important ones in here to look at. The emission rate. This is how fast we're emitting particles. Okay, we're emitting 30 particles a frame here, so that's pretty intense. Okay, so I can dump this down to like 1, and now, boop. There's some randomness in there, which is cool, but pretty slow. You can increase the emission rate, and now start pumping out more. Here it is at 100. You can see what we're getting. So the emission rate determines the speed. Now the emission type, when it was down at 1, did you see that it was random? It was sometimes I was getting 1, but sometimes I was getting 2. Like I just spawned out 2. That's because the emission type is set to random, right? So it's not honoring that frame rate or that emission rate precisely. It's doing a couple particles a frame. Others it's not even 1. However, if we change it to uniform, bloop, 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 now it's kind of uniformly generating those particles. They're still going in random directions. Yeah. Oh, okay. Stop your sim. Hit the A key. Let's see if that does it. Oh, do Shift A. There it is. Yep. Now, in order for us to change the angle of emission, we need to go in and change the cone angle. Okay? At an angle of 180 degrees, you can see that it's basically, kind of going all over the place. Okay? But we can start to direct our particles by reducing that cone angle. There we go. And now we're controlling a little bit how our little nozzle, our emitter, is firing these particles out into the scene itself, which is pretty cool. The angle spread, if you look at it from the front here, let's see. Yeah, see how they're always being generated with inside that cone angle? Upon generation, they're never going outside that cone angle. But if we do angle spread, it kind of loosens up the boundary a little bit, if you will. And now some are being emitted outside, some are being emitted in. It's just adding some variation. Again, adding kind of a new organic layer to how our particles are being generated inside of the scene itself. I want to put my angle spread back down to 0. So they're just going to kind of honor the angle of my emitter, which brings us to velocity. Okay, what do you think this is going to be? How fast? Yeah, this is how fast they're being emitted from the emitter. Yeah, go ahead.
Sorry, is there a way to make this particle itself bigger so that instead of like spawning in one spot,
A whole bunch, yeah. We'll get to that in a second, but yes, you're absolutely right. Yep. Think of that's these two down here. Yep. Because right now they're coming from a point, like tip of the pyramid. By changing the start radius, we can widen the base of that pyramid. So the velocity is kind of important. This is how fast they're being shot out of the emitter. Okay. I'm at 750 millimeters a second. Okay. Let's put this down to something really low, like 10. Now they're going the opposite direction. Let's increase it a little bit. There we go. 197, I wanted to go up. But why are some going fast and some going slow? Yeah. The spread determines kind of a range of speeds that they can be generated at, right? So, range. Some are going to go real slow, some are going to go real fast. If you want it to be, this is, I can't remember off the top of my head if this is a multiplier or if it's additive. Can't remember off the top of my head. But if you wanted to honor just the initial velocity speed, just put this to 0. And then every single one will be generated at the exact same speed. The spread just gives you some randomness. Yeah, now they're all going the exact same speed, which is kind of cool. And pretty much in the exact same direction, which is also kind of fun. Now, earlier, Adrian said, is there a way for us to increase the base? And that's the start radius. If we keep increasing this, let's see, yep, now they're being generated from up here. But we're creating the illusion that instead of coming from a tip, coming from a much larger base. And we can also extend that out a little bit. There we go. Yeah, I went a little too far. Yeah, now some will be generated outside, up and below. So we can just kind of go in and vary it a little bit in here as well. Now these emitters are a tremendous amount of fun because once we start tying them in, and I should know better, but I'm going to do it anyways. If you think about it, at the core of our replication system are verts, right? We've just created an emitter whose sole function is to create verts inside of the scene, okay? Let's see what happens when we start wiring our emitter as the point source for our replicator. So I'm going to go down to the point source on my replicator. I'll leave my prototypes to cars, but now, instead of using that point source mesh item like we did last time, I'm going to load the particle simulation as the point source. And let's just sit back and enjoy this for a moment, because this is going to be wacky and weird and awesome. Oop, I don't have my replicators. There he goes. They're just so gigantic and big. Cool, huh? Let's see, let's really break it. Now, the center points of all of my items, of all the items in my group, are really what's most important. Hey, let's do this. Let's put my start radius down there. Let's play it again. Yeah, that's lovely. I'm also going to go into my viewport properties and change my replicators to selected. Let's start the sim now and see what we get. There's a NASCAR. Cool, huh?
What is this?
Now we're moving. Okay, so given the context of what we've been talking about today, this is in every sense the underpinning of like a traffic system, right? I can kind of establish an angle that I want to spit out these verts. And let's just do it real fast. Let's just see if we can. Let's look at my scene from the top. Now, right now, I'm spitting the verts out vertically. So let's take my emitter, and I'm going to rotate it back 90 degrees. Yeah. Awesome. Now the center point for a lot of these things are off. And I'm also giving it some offset in here on the replicator itself. the randomness to 0. There we go. That's pretty entertaining, right? However, we have a little bit of a problem in this. What is my problem? They're all going the wrong direction, right? So we need to go in and start modifying our particles a little bit. We need to go in and start telling the computer, hey, you have these particles, now you need to like rotate them a little bit, okay? This is where our P mods, our particle modifiers, come in, and they allow us to, we don't have the ability to do those transform maps when we're working with emitters, right? When we had that, when we're working with static particles, then I could go in and individually select the verts because they're static, they're not part of the simulation, and I can rotate them, move them around, and kind of massage their attributes. But when we're working inside of a simulation, I can't individually do that, right? So I have to have another kind of systemic, component of the simulation that's going to like rotate all of my particles 90 degrees for me. Okay, those are called particle modifiers. Okay, and if you look over here, you have a whole bunch of particle modifiers. The only one that you don't want to touch is the generator, because that one actually creates static particles. We'll save that one for another day. It's pretty neat, actually. This is where our schematic starts to come back in play here. And I think, let's see, before we go any further, I want to increase the velocity of my emitter. See if I can start spreading these out a little bit. There we go.
How did you get your cars all here on the same kind of surface? Because mine like go here in like a cloud.
Yeah. Go back to your replicator. Did you do some, you did some, go back into your replicator. You did some random offsets.
Oh, right,
yeah.
Right.
Yep. I had forgotten that I had done the exact same thing, and I went back and changed it. Okay. All right. So let's see. I think this is good enough for what I'm doing. Let's mess with it a little bit more. See if we can space them out a little bit before they're born. There goes the NASCAR, the race car, the Alpha. I love it. Love it, love it, love it. That's pretty fun. That's very fun, actually. Okay, but now we need to get them to rotate. I need to rotate all the cars so they're facing the right direction. So this is where the particle modifiers come in. And again, our schematic is going to play a big role in the tweaking, if you will, of our entire simulation. I want to stop my sim for a second and start loading all the items that are creating the sim into my schematic, just by left-clicking and dragging them down there. Double-click on the gold diamonds. That's a group, FYI. This is what a group looks like in the schematic. Okay, and you can see pretty quickly how all of this is thrown together. We have an emitter, which is sending point information as an operator into the particle simulation. The output of the particle simulation is now the point source for our replicator, which also has an input property for the prototypes, for mesh. Okay, so this is how it all wires together. Now I want to go in and begin to modify my simulation a little bit. Add a new operator that's going to rotate all of my particles 90 degrees, or any number of things. And this is where it can get really fun really fast. Unfortunately, this is also the part where it gets really complex, okay? But we're going to keep it simple today. And then if you want, we can definitely continue to explore this over the next couple weeks. Like I said, this is a deep rabbit hole, okay? However, let's go ahead and add the particle modifier. If you start with your sim selected, the particle modifier that you select will automatically be wired into that sim. So let's just do the basic particle modifier. Particle? That's not good English. Particle modifier. Okay. Now this PMod, as they're often associated and referred as. At the moment, nothing's really changed. You can see all of my cars doing the exact same behavior. But in the PMod, the particle modifier, check it out. Now I have position values, I have rotation, Let's change this to 90. Let's see what we get. Did it rotate it? Should have rotated it. Oh, I need to stop it. Thank you. Oh, it's crashing it. Yeah, I certainly didn't like that. Let's see. Maybe I did 90 degrees on the wrong axis. Okay. Point sources, vertices. Yeah, that should be right. Last but not least, is it the Z? No. Why is that not working? Maybe I did the wrong one. No, I'm 100% sure that's the right one. Well, that's bizarro, isn't it? Actually, I think this got wired in. No, I guess it did get wired in correctly.
Did you wire it to the particle simulation or the ship?
To the particle simulation. Yep. Hold on, let me see. Let's put it back here. Okay, let's try it again. 90 degrees. All right, just to make sure I'm not going crazy. Sometimes I need to reaffirm that I'm not going crazy before I go any further. I like these particle generators. These particle generators are pretty neat. So what I just added in here was a particle generator. This is just going to create some particles for me. It's going to create them in a very defined parameter. This is going to create, in an array. I can also make them linearly. You'll see this when I hit the play button. Or not. Nope, they're probably right down there at the origin. Particle generator. Oh, that needs to be part of a. Here, let's do this. Yep, there we go. My properties are all wrong. That's fun, isn't it? Okay, so now, there we go. That's awesome. Yeah, okay, so I'm just confirming here that I'm not, in fact, going crazy. Because this particle modifier, the output goes there. Yeah, okay, I'm not going crazy. Okay, good. That's good. The particle modifier did exactly what it should have been doing, right? Because now it's rotating the particles. Yay! So now the question resides: why was it not working on the sim? Okay, these particle generators are pretty neat, but they're static. They really aren't participants in a much larger simulation. We can influence them in an animated way, but we can't dynamically influence them, which is a limitation of the particle system at the moment. Let's get this back working together. I'm going to put my replicator back into my particle sim. Now I'm blasting out cars again. This particle modifier is going to do that. There it goes. Okay, I have no explanation for why it wasn't wired. Maybe I just had it wired up wrong. Yeah. Yeah, I think I just had it wired wrong. But now it's working. Because now I can put it 90 degrees on the Y. And it works. Like I said, some days I can't chew gum and walk down the street at the same time. But so there it is. That could be it. believe it or not, once I get the spacing kind of established on the emitter, I now have the underpinnings of a traffic system. All the cars are being spawned differently at different times, and they're even. If I increase the velocity spread here a little bit, now some are going to be speeding, and some are going to get a ticket for going too slow.
Would you, if you were doing like a traffic system, would you make like 3 or however many lanes you had? And you
Yeah, just have a couple lanes. Yeah, and right now the cone angle is like this, so I'm actually blasting it out at an angle. But if we completely zero out our cone angle, it should, now they're all going in a straight line. Yeah. Now, why are they kind of disappearing over here? Has anyone figured that out? Particle life. Yeah, you got it. So if we go, and that's established in the particle simulation by itself. See, it says maximum age 60. Okay. At frame 60, or when a particle is 60 frames old, it's going to be removed. Okay. So I can extend this. Let's put it to like 120. And now my new particle should stay on. Oops, I'm not culling by age. Sorry, forgot to turn that on. Now the new one should stay on scene a little bit longer. Oh, the other reason why they're not staying on scene is I'm not running the sim from the timeline, so the sim didn't have any idea of time. If I put the maximum age to like 30 and then play the sim from the timeline, they should die pretty quickly. Yep. So we can't control it. All right, should we kick it up a notch? Let's kick it up a notch. I'm going to unwire my my replicator from the cars group just for the time being. And let's start having a little bit more fun with this, because this is fun. This is kind of cool and neat. But let's really see if we can make something compelling, like a waterfall. That'd be kind of rad, right? A waterfall. I'm gonna need some parts and pieces in here. Let's do this. I'm gonna have. See, I have a ground plane, or I had a ground plane. The ground plane is kaput. Let's make a new one. Oh, it might help if I did that on a mesh item, huh? There we go. All right. Yeah, okay. And on that ground, let's see. Yeah, let's do this. This will be entertaining. Let's make a bowl. I'll make it a real easy bowl. Just make it a sphere. Okay. Do an old school thicken here. There we go. Give my bowl some dimension. There we go. So there's my bowl. Okay. Maybe the bowl needs to be a little bit bigger. That's kind of a small bowl, right? Okay. Hold on a sec. I'm being a nerd. There we go. So I want to make this entire object here, this entire item, let's see, I want to make this, so I want to have like a cup or like an emitter spew some particles out, like a waterfall, and they'll be collected in this bowl. So what type of rigid body should I make the bowl in the ground? Static, yeah. It's not going to move, right? We're not going to animate it, okay? We just want it to be a member of the dynamic simulation, but it really doesn't need to Doesn't need to move. So a static rigid body is really what we want. I'll go into my Dynamics tab and just do static rigid body. Okay. Now I'm going to go back to my emitter for a minute, and I want to move it up. I'm also going to increase the cone angle a little bit so it's spewing out from a fun little, there we go, fun little angle. Let's test it. I'm also going to increase the emission rate quite significantly. Let's put this to 300 randomly. So now I have a whole bunch. Let's move my emitter up a little bit and lower the cone angle. So now I got a fire hose. But they're all being culled by the time they get down to the bottom. So let's do this. And I'll also change their cone angle a little bit. There we go, something like that. Okay, cool. Now, what I got to do is that I got to bring my particles into the dynamic simulation and have them be a member of this wonderful understanding of gravity, right? Oh, before we go any further, I forgot to do this. I forgot to turn on gravity on the sim itself. So let's do use gravity. There we go. So now it's a little bit more of a realistic emission. And I'll also increase the start radius. There we go. There we go, that's pretty cool. One of the reasons I love that first button in our sim tools is that I can make changes to all these parameters and see them live in front of me, right? It allows me to go through my feedback loop pretty quickly. I hit the stop button. And let's see if we can make these dynamic particles now. My velocity on my emitter is set to 9.85 meters per second. So it's pretty high. Let's actually bring it down lower than that. There we go, it's a little bit better. Now they're not shooting out as far. Cool. All right, let's make our particles here dynamics, or dynamic particles. And of course, we'll have to go back to our particle effects. And I want to make this a dynamic collider. And let's just see if it works. Cool, huh? It is, in fact, working. However, we have some that are escaping. That's interesting, isn't it? What's going on here, you think? My collision shape is not right, and some are bouncing, coming up, and then bouncing down again. Yeah?
And it's not going directly into your ball.
Yeah, so let's change the collision shape on our static rigid body and see if that fixes things. I want to stop the sim, go to my bowl, and under its dynamic properties, let's change the collision shape from multi-hole. I'm going to experiment. Mesh and then convex decomposition are two good ones to begin to explore, and I really don't have an answer for it yet. My understanding is that convex decomposition is a step in the right direction because it's really designed for things that have holes and opening. It's not as processor intensive as mesh, but it's still processor intensive. So let's try that.
How did you make the particles dynamic again?
So I selected the emitter,
Okay.
and then in the particle tools, I simply selected dynamic collider. Yeah, let's see what we get. Kind of the same thing. Let's try mesh. There we go. Cool, huh? I could do this all day. If I made the properties, let's make it really bouncy. Let's put them bouncy to 70%. Now some of them should bounce out. Yeah. Cool, huh? Now, okay, let's get really crazy here. I'm going to turn my emission rate to 10 on my emitter. That way I can kind of see and understand what's going on. Yeah, let's do this. I'm not going to wire in my cars group to this because this would be maddening. But I think I'm going to make a simple little cube. Because there's one final thing that I want to show you guys, and then we'll start working on our homework. Okay, I'm going to make a simple little cube because it's not too gigantic, and even then, my cube is a little bit big. I could modify it, using a particle modifier and make it smaller, but that will do, I think, for what we're going to be accomplishing. Now on my replicator, let's do my prototype set to cube. There we go. They bounce around, which is kind of fun. But what aren't they doing?
They're not rolling around or anything like that. They're keeping still.
They're keeping static, right? Yeah, they're not really, they're just dropping. They're not rotating as they drop. And if you look carefully, we're getting a lot of cross collision in here too, right? The outside hull of the cube is not being honored by the other particles in the simulation, so they're crossing through each other, okay? We can fix this, okay, by making it a dynamic replicator, okay? Let's do this. Is actually kind of cool. So we've got to have our replicator selected, and they've hidden it for whatever reason. The guys and gals down at the Foundry have hidden this little awesome nugget inside of the Add Item pull-down menu. It's under Particles, I believe. I take that back. Where is it? Simulation, Dynamic Collider.
Is there a reason why one uses the offset from the particles?
Oh, it's under dynamics.
Is it? You define it under Dynamics? Yeah, you may have moved the polygons separately from the item.
Yes, there's
Indigo?
center.
Oh.
Yeah, it's the center points are Dynamics. Here it is, Dynamic Replicator. Okay. Now, let's see. Is it working? I don't think so. It may not be wired in correctly. Let's triple check. Yeah, why did that not work? Let's see. Yeah, they're still not touching each other. Let's see what's going on. It's not a member of our solver. It's not wired in correctly. Let's see. Why is it not wired in correctly? Hold on one second. Let me consult something. I was working with this earlier. Yeah, the output of the dynamic replicator. We're getting there. And the prototype. I think I need to bug this. Yeah, because the prototype I think is also no, that's not working. I gotta figure this out, but there's a way. I don't know why it's not getting wired in correctly when I added it to the list. Dynamics. Yeah, but It does work. I'm just messing it up. Let's see if I can figure it out. Oh, you know what? I still have a particle modifier in my system. Let's get rid of that real fast.
Is there any particular reason why this doesn't work with lights, apparently?
I'm sorry, say again?
I said, is there any particular reason why it doesn't really work with lights?
Why it doesn't work with lights?
Yeah, I tried to get the particle system like work with the lights and whatnot. It did not work.
So the whole idea is that you're generating lights instead of a mesh. Yeah. So how we render particles is a little bit different. Okay. Right now we're rendering pieces of geometry. I've never actually tried to have it render a light. Maybe the alternative would be to not to actually generate a light item, but to make that mesh luminescent, okay, or luminous, excuse me, so it's simulating a light. Yeah, that may be the way to do it. All right. I want to see if I can get this to work. I'll tell you what, while you guys are beginning to work on your homework this week, I'll start see if I can figure out what's gone wrong with my dynamic particles and why the replicators aren't honoring their own self-collision. I've gotten this to work a couple times. I think I've just got my wires, literally I have my wires crossed down in my schematic at the moment. So the homework this week is that we're going to be making a domino rally. Okay? Let's stop my sim. Let me fix that. I probably did not activate or make the page visible when I was working on it earlier. Let's see. We are on week 10. Oh my goodness. Oh yeah. I'm sorry. The homework subcategory was not visible. Refresh your page now in Canvas and you should be able to see it. So our homework this week is to simply make a domino rally. Okay? So I want you to be creative with this. Think like Rube Goldberg machines. Have you guys ever seen a Rube Goldberg machine? I'm sure you have. What?
Flubber.
Flapper?
Flubber. I think it means flubber.
Flubber.
You know, like the Robin Williams movie with like the goo.
Yeah. All right. Oops. All right. So your job is to make a domino rally. Okay? It's going to be about 10 seconds. Have fun with this. Make it complex. Make it intricate. But don't make it so hard that it's impossible for you to get the result that you're after. Plan it out. So just to give you guys a little bit of context here as to where we're going. If you were to go onto YouTube and simply search for domino rally. Here we go. This is what I'm talking about. Okay. Yes, Stranger Things is coming out tonight. How awesome is that? Warning, this video is old. Okay. But this is a domino rally, right? So your job is to come up with one of these, okay? And to create one.
Do you have an objection against memes?
No.
Good idea.
This is one example of many, right? Think creatively on it. If you think about it, this is the great application of dynamics. To help you out with this, one small thing, and this actually speaks directly towards the homework this week. How are we going to set up all these dominoes? Let's talk about a workflow that you could employ to quickly get you to this end result. Because if you have thousands of these things inside of your scene, how are you going to make them work? I want to stop you in trying to get replicators to work for all the dominoes. Don't go down that route. It's not going to work. because replicators don't work with static point clouds, okay? Or dynamic replicators don't work with static point clouds. Dynamic replicators only work with inside of a simulation. So at the moment, we can't really use the replicator system and that engine to get us where we need to go. And so instances are where it's at. However, here's a great suggestion. We can pair some really great technology that's currently in the app to get us to what we need really quickly, okay? Let me show you specifically what I'm talking about. I'm actually going to create a new scene here because things are getting kind of messy. Check it out. We have a really cool function inside of Modo called a curve particle generator. Check this out. This is neat, okay? So let's first go in. I'm going to create a new mesh item. And on that mesh item, I'm just going to throw down just kind of a standard Hermite curve, okay? Okay, that's the path in which I want all of my dominoes to be created on, okay? Let's name it. It's good that we name things. Oops, can't spell today. Curve. Let's create a new mesh item. I want to call this domino. Actually, I'm going to call this domino prototype. There we go. And on my domino prototype, let's go in and actually physically create the model itself. Last time I checked, dominoes are this shape-ish.
2 by 1 by 1 quarter.
What?
2 by 1 by 1 quarter.
Let's get exact, okay? So you said it was 2 inches. 2 inches by 1 inches by 1 quarter. Is that what I heard? Yep. 0.25 inches. There it is. It's very small. It's rotated 90 degrees too, but we can fix that. That's okay. There it is. There's my domino. Let's rotate it. And before I go any further, let's do center selected all, because I want that chilling just right down there at the origin of my scene, and me being me, and just really make my life hard at times. Oops. Okay, I can be a happy camper now. No, I can't. Okay, now I can be a happy camper. Okay, whew, there we go. Wait, actually I'm not done yet. I'm not done yet. Okay, now I'm done. All right, so there it is. There's my little domino. Now I can start replicating this domino. So this is really kind of a 2-part sequence that we can go through, because we want to be able to place these dominoes quickly. However, we need to change our approach ever so slightly at the end of the placement to be able to make the dynamic simulation work the way we want it to work. Okay, so here's a good workflow. It's not the only workflow, but this is a good one to begin with, because it's going to get you to your end result a little bit faster. All right, so I got my domino. In seeing the size of my domino, perhaps my curve is a little too big. Let's make it a much smaller. And I'm also going to center it in the scene. Let's see, am I approaching the appropriate scale? That's a lot of dominoes. There we go. Okay, now I'm happy. That's kind of what I want. All right. So let's go ahead and actually start wiring all this stuff together, because there's an extra thing in here that we can add that speaks quite wonderfully to what we're trying to create. Okay? I know that I'm going to need a replicator, okay, to make the dominoes. However, I also know that I need to create a curve particle generator. Okay? You can find this under the particle section in the Add Item pull-down menu, under Point Clouds and Curve Particle Generator. Now the purpose of this, the exclusive purpose of this, is just to help us place the dominoes quickly. Okay? That's all it's going to do. Let's wire it together real fast. And under the replicator, prototype, of course, is going to be the domino prototype. The point source is going to be the curve particle generator. And I got not a single thing, so let's see what's going on. That's because I didn't tell the curve particle generator what the source curve was, which is going to be the curve, the mesh item that contains the curve. And there are my dominoes. Okay. Now, what's cool about this is that I get to figure out the distribution of my dominoes along the curve by increasing the point count. They look a little too far away from me, so let's put it 30. I'm in every sense trying to guess here. I'd much rather have them be too close than too far away. Trying to visualize if that one knocks over, it's going to hit into that one, and I'd say yes. Now, why this is rad and why this is definitely the preferred way of getting us to our end result is that the curve particle generator is taking its shape from the mesh item that contains the curve. Any change that we make to the curve, as one might imagine, is going to change the particles. Okay? So I can do my initial setup quickly, right? Because I'm not having to individually place all of the dominoes. If you are individually placing all of the dominoes, stop, time out, pause, rewind. We need to rethink your production pipeline because that is maddening, right? That is not an efficient production pipeline because if you have 10,000 of these things, you're not doing this by hand. Okay, you're not individually. That would just be like, no. This is why we have computers, right, to do the hard work for us. However, and this is the dilemma. The curve particle generator does a great job of creating the particles, placing the dominoes where we want them to be, but it won't participate in that dynamic replicator that we were seeing before, right? So I just can't wire this into a dynamic sim and have it go. So here's the problem, or here's what we need to do. I forgot to add a ground. Because I'm doing it, man. I'm going the distance.
Are you on your way?
I am on my way. Just like Hercules.
How far?
Just like Hercules.
Do you care how far?
I don't care how far. Okay.
Okay, I'll stop.
Yeah. All right. So let's get this. Let's hooked in. This is going to be, the ground plane is going to be a static rigid body. Okay. We actually need to have a duplicate. I need to have another domino to actually fire off this whole thing. So I'm going to duplicate my prototype. And I'm going to call this one domino start. Why not? And I'm going to position it. So this is probably the only one that you're going to individually position. Something like that. There we go. Okay. Yeah.
I duplicated my domino, and I found that half of my dominoes are controlled by one of them, and half of them are controlled by the other domino.
Interesting. Yeah. I don't know. That's a good question. All right. So here is the dilemma. Okay. Right now, I can't send all of these particles into a dynamic simulation exclusively by the limitation of the tool set. And I've asked. I've been banging my head against this for the last 7 days, trying to figure out, is there a way that we can just send it automatically like we can in the other simulations? And the answer from the developers was, no, you can't do that. We can't, static particles cannot be part of a sim, right? They're just static, they don't move. So we have to convert it. We have to convert basically we have to freeze our replicator into instances, okay? And it's really, really easy to do this. If you hear one thing this afternoon, hear this. This is the last step. This is the last step, because you're about to create, 40 individual instances inside of your scene. So you want to save this step until the end, okay? And yeah, just save it to the end. To do it, it's really easy. Just notice that I got my replicator selected. If you go to the top of the screen where it says Item, it's down here under Replicators, and we're going to freeze the replicator. Okay? Now what this is going to do, it's going to take the current location of all the dominoes and basically push it into its own instance of the domino. Okay? Bloop. There it is. Notice that the wireframe outlines for all of my dominoes have in fact gone pink. Over in my item list, we now have a group locator that contains all of my instances. Okay? I can grab all of these things. I can make them dynamic. Let's make them active rigid bodies. Okay? There it is. Now, to start the sim off, let's see. Oops, I clicked on the wrong one. My domino start. I need to give him a little bit of a push, right? So what area inside of my dynamic properties should I look towards to give him a little bit of a push?
Impulse?
Yeah, it's going to be impulse. Force is something else. Impulse gives it a little bit of oomph, right? Gives it a little bit of a shove. Now I need to figure out which direction. We're going to shove it. Oops, looks like I was a bad boy. I rotated it independently from the item, but that's okay. We'll figure that out. I think if I still just shove it along the z-axis, I'll be okay. So let's do on the z. Let's try -1.
Could you also make the first domino a kinematic rigid body and then animated? And that would have
You could. Yep.
Okay.
Oh, that did not go well. Make sure that everything else is legit here. Did I make these all dynamic? Yep, cool. Domino start, dynamic. Let's give it more of a push. It's probably, that could also be it.
Oh, I'll type in interesting.
No, didn't even work. Shouldn't be. There's the floor. They're not even falling. Aha, I think I know. I'm going to make these undynamic for a second. And let's just see. The reason I'm doing this is just to troubleshoot this first one. The fact that the first one isn't doing anything is an indicator that something is going wrong. Because at the very least, here, let's raise it up a little bit more. At the very least, the first one, yeah, did I make the first one dynamic? I did not make the first one dynamic. I thought I had. So here's my problem. Like I said, it's the end of the week on a Friday. My brain's just going to crap. Yeah, so now that it's a dynamic item, it's doing what it should be doing. Thank you, Domino. Let's put you back where you were. Goodness. Man. Who is in charge today? Not this guy. All right. Put him back on the ground. I'm also going to make him, he looked a little too light. So I'm going to change his mass. Let's put it at 5 lbs's, 5 pounds. It's a very heavy, yeah, they're all working now. That's good. It's a very heavy down, but what I'm going for is just an illusion, right? I'm going for a look, not an actual recreation of reality. So at that weight, at 5 pounds, let's give him a little bit of a push. Too much of a push. I love how some of them are working, some of them are not. I noticed that. Yeah, I got to figure out why. Negative 0.25. There we go. All right, so now I'm in troubleshooting world. It is in fact working, but it's not working well. Why isn't it working well? Let's figure this out. Some of them are domino start, and some of them are domino proto. That's interesting, isn't it? Yeah, some of them aren't. Okay, let's troubleshoot. Okay, the one that I got selected is proto. This one is also a proto, and it's doing it. Wait. Okay, so that one is doing it. Yeah, so I must have messed up somewhere along the way.
Seems like the prototype ones are not, are like not kinetic.
That was unexpected. There we go. Here, let's make them undynamic. Make them dynamic again. Now they've all been made dynamic, but not all of them. Well, that's bizarro, now, isn't it? Got to figure that one out. It is cool, though. Okay, looks like the root cause is my replicator. So let's just delete them. Let's get rid of all those and rewire everything in together. Maybe I made a mistake in my process. I always have to assume that I messed up. As strange as that sounds, always assume that you missed something. Prototype. Okay. Yeah, that's something, isn't it? Because now my point cloud's at 40, but I'm only getting 5. Something in the process of me getting this to work. A wire got crossed somehow. Let's see, let's add in, I've deleted my curved particle generator and my replicator. Curve, replicator, I want you to replicate the prototype, the point source. Go. That's what I'm after. Okay, we're getting somewhere.
It's only replicated half of them.
Well, that's because I increased the particle count to 40. So now I have the appropriate amount. Okay, let's see where we've gone wrong here in all this. Grab the replicator. Yeah, now they all say proto. Thank you. I must have, maybe I had the first one selected. Okay. There it is. Cool. All right. It works. Now I just got to go in and tweak it a little bit. Get my impulse back here. Oops, pushed it the wrong way. Negative 0.25. There it is. It works. If you have some that are falling over prematurely, adjust their weight, make them real heavy. Okay? Like there's some over here. I mean, they're just so light. Let's make it 10 pounds. There we go. Oh. It's mesmerizing, though. Let's go in and change some dynamic properties. I could do this all day. Let's change the bounce friction to 0. Oops. Let's put the friction to 80. I went the wrong direction on accident. There we go. Except all of these are crazy light. You know what may be happening, what my brain is looking at, is that I'm watching my animation go, and I wonder if a force is being transferred in the ground plane, effectively creating like little shock waves in the ground planes that are making the dominoes at the end of my run bounce and fall over. You know, oh, one of the things that we can try, this might be kind of fun, is that we can actually activate them. Yeah. See under this sleep section here? Instead of at the beginning, when we hit the play button, we activate their dynamic understanding. What if we do, let's try collision force. So now, if something touches it, yep. Nope. Oh, I only did it on the second one. I forgot to do it. Let's do it on all of them. Let's change the wake on collision force. See if that has an impact and stuff. There she blows. That's it. That is very satisfying. I could watch that all day. I'm looking forward to seeing the mad scientist machines that you guys create.
How long does the download hour really like?
Yeah, make it about 10 seconds. Yeah, make it about 10 seconds. So you got to craft something that's pretty intricate. Use all the tools that we have at our disposal that we've talked about so far to get you to that end result. Okay, we've talked a lot about constraints, active and kinematic rigid bodies. Have fun with it. Be inspired. Look at some of those Rube Goldberg machines that you find online and generally try to be inspired by something. Let's see. We started this process earlier. So domino rallies are pretty great. Let's look at this one for a second. Whoa. Can you imagine having a hand place each one of those dominoes? No, I can't imagine that either. Okay, I want to check out this one because this one looks cool. Sorry. I'm easily distracted. The amazing triple spiral. You had me at amazing. Check that out. Okay, bonus points will be awarded if you do this. 25 hours. Look at that. Can you imagine? You have to have the stability of like a Greek god to do that. Just like my hands shake. I drink way too much coffee, so I'm the wrong person to be placing each one of those. Look at it. Look at it go.
Oh, it's going to go in and out.
That's cool. And it's going to collapse. There it goes. Yeah, I wonder when it's going to go on the support structure ones. Yeah, and something complex like this, look at that. There it goes. There it is. Something complex like this is a really great opportunity to make multiple render cameras and then do that interactive camera switching that we explored earlier in the semester. This is perfect for something like that.
It's more like a quadruple spiral.
Right? 24 hours, 25 hours worth of work gone in
They must have planned it
2
ahead,
minutes.
though.
Oh yeah, you can't do something like this randomly.
That
No.
would just be like the domino placing work.
Yeah. Oh, yeah, I'm sure. Yeah. 25 hours. 3 full days of just placing. What if you accidentally bumped it over?
Spread over 8 days.
Spread over 8 days. Yeah.
There's this video of this kid, he was making like a domino like Death Star or something.
Look at the words.
Accidentally, like, moved and it's all
If somebody's saying that's
What? Okay. Advertisement. Go away. They did a pyramid. Okay, I want to see the pyramids. I don't want to see the other things you've made. I want to see the pyramid. Although that is cool. Where do you go to buy dominoes like this? Is there like an online retailer that I'm just not? Look at that.
I'm sure
That's
there-
sweet.
I'm sure there are people online that will sell you millions of them.
Right?
Pretty-
It's a niche industry, cottage industry.
I mean, these aren't plain dominoes either. They're
They look like plastic dominoes, yeah. Oh, it's going towards the pyramid. Full screen? Yeah, sorry. There it comes. The big pyramid. It's just beautiful destruction, right? You can't go wrong with beautiful destruction. The other angle, world's largest domino 3D pyramid. 16,000 individual chunks.
still going.
That's cool. Oh, they made a tree. Is the tree gonna fall down? I want to see. Oh, there it comes. Oh, fail.
And this is what's called too much free time.
See, aren't you really happy we're doing all this digitally now?
Yeah, from what we got, yeah.
That's cool.
I don't think it's like too much free time if it's their passion though. That's pretty awesome.
Yeah, I mean, okay, yeah. I think Christine makes a wonderful point. Take a step back. How many hours do you guys play video games every day? I know some of you guys are logging like 6-7 hours in a single day. Okay, imagine doing the exact same. Imagine if you were to commit that time to doing something like this. You'd make something that's pretty special. You know. All right. Questions on what we're going to be striving. Oh, one other thing. This is actually something I want us to start getting used to doing, and this is a perfect opportunity for us to explore it a little bit. Okay. The render size for our homework this week is bigger. Okay? Does anyone off the top of their heads understand or remember what the default render size in Modo is? 1280 by 720. You got it. 1280 by 720. Does anyone know what this is commonly referred to out there in the world of HD signals, video signals? Huh? 720p, right? We have kind of graduated past 720p as the go-to image resolution. 720p was always kind of like the starter HD resolution. Okay, it's a good resolution to begin with, but every television, so basically every screen out there, even this thing over here, is of larger resolution, 1080p. Okay, shoot, even my cell phone has a 1080p screen on it, right? So we need to increase our resolution to match the minimum screen size that we see everywhere on the face of the planet these days, okay? So starting today, everything that we render is going to be rendered at 1920 by 1080, okay? I've put those details in the assignment sheet. Specifically, how do we change that over in Modo? Because it's not the default numbers anymore. So we do it in the render item itself, right? If we explore the properties found in the Properties tab, there's your blues, frame width and height. Okay, 1920 by 1080. Everything going forward is going to be rendered at 1920 by 1080. Since we're increasing our render size, is this going to have a positive or negative impact on our render times? Negative. Start planning for it. It will take a little bit longer to render because now we're physically rendering more pixels. The image just got much bigger, okay? If there's one thing that we have to all, collectively as a 3D community kind of get past is render times. Render times are just kind of, they are what they are, okay? We're not rendering at the feature film quality level yet, okay? We're rendering at about half of what they're rendering for The Last Jedi, okay? at 4K. Actually, they're probably rendering at something higher than that. They're probably rendering at 5 or 6K and then windowing and taking a portion of that final image and having it show up on the screen itself, okay? So we're not even anywhere close to what the big boys are doing it at, all right? So we need to get used to working in higher resolutions and committing the time to rendering correctly at those resolutions, okay? It will take a little bit longer, but this is the cool added benefit is that all of a sudden your work is going to look really awesome because now we physically have more pixels to describe one of the dominoes for that effect, okay? It's pretty neat. And this is another really great example of where I would encourage you to go in and enable motion blur on your render. If you have some time to render, like a good all-day render for this thing, enabling motion blur on your camera is going to be pretty cool, okay? So you can do that by selecting your camera. It's under Camera Effects, and then just turn on the motion blur, okay? I'm going to go to a frame here. I haven't cached my sim, excuse me. Let me cache my sim. And I'm going to go to a frame where my dominoes are in fact falling on my timeline. That'll work. And if I render, you won't get a preview of motion blur. Well, actually, you can turn it on, but check it out. Look, you can actually see the motion blur in the final render, and this is going to make your animations look butter smooth and cinematic and just really pretty. Because whenever we capture something with a computer or with a camera, there's inherent motion blur added in the image. That's not on by default in the computer, right? We have to enable it, and we have to turn it on. And with it on, you can see that now we're producing something that looks a little bit more cinematic. It doesn't look as computer generated as we've seen before. This is a really great project to kind of wet your feet, if you will, into the motion blur world on your camera effects. Yeah, it's pretty good. That was 1920 by 1080. Still didn't take forever, about 40 seconds a frame. Yeah, pretty cool, huh? Pretty cool. Oh, one thing, as you go into the idea of rendering this thing over the next 7 days, crunch some numbers. The render time shouldn't be a shock to you, right? You shouldn't, sit down in the design lab, hit render, and go, oh, I didn't think it was going to take me 8 hours to render this thing, right? You should know exactly how long it's going to take to render this thing before you sit down and actually render it. How? How can you figure out that number before you render?
Do one.
Render a frame, right? Render a frame, and then literally crunch the numbers. Okay, 10-second animations, 240 frames. Okay, if it takes me, I can't read that. Does that say 41? Okay, 41 times 240. Here, let's just do it. Let's add the calculator in here. Bloop. All right, so I got 240 frames. They each take 41 seconds to render. Okay, that's 9,840 seconds. Okay, how many minutes is that? What do we divide it by? 60. Okay, 164 minutes. How many hours?
About 3.
2.7 hours. Okay. Now we know exactly how much time it's going to take to render this thing per frame. It shouldn't be a surprise. I got a lot of people over the last couple days coming to office hours saying, Pat, I didn't think my animation was going to take me 3 hours to render. And I said to them, well, crunch the numbers. Don't have it be a surprise. Okay? This stuff is as hard as you make it. Okay? Part of being a professional is learning how to budget your time, so know how much time you need to budget. Okay? By rendering a frame, crunch the numbers. It does. Give yourself some wiggle room. Yeah, there are more intense frames than other, and this will go up when you start adding in textures, materials, changing the lighting and the global illumination settings. Yeah. But at least we have a starting point, right? All right, let's get to work. Let's do it. Yeah, shiny things, believe it or not, shiny things take forever to render correctly. Yeah, we're going to have an entire day, probably the last class or maybe the next to last class, about rendering. I have a really good project. Some of you guys saw me rendering my little fan. A really good project that will visualize maybe a really solid rendering process to get your frames efficiently created. All right, let's get to work.